Hello students. So now we are going to discuss about the biomechanics of hand. Before starting with the biomechanics, we will just discuss the overview, the structural anatomy, that what are all the structures that are present in the hand complex. So basically we have 5 digits, 4 fingers and 1 thumb. Okay, and inclusive of these 5 digits we have 5 metacarpal bones. These are the metacarpal bones, and we have 14 phalanges. These all are the phalanges. So what are all the joints that are present in the hand complex? So each finger, it has one carpometacarpal joint that is present between the carpal bone and metacarpal bone, and it has one metacarpophalangeal joint that is metacarpal and between a phalanges, and then 2 IP joint that are interphalangeal joints that is between the phalanges. So we have between these two, this is the proximal interphalangeal joint, whereas this one between these two is the distal interphalangeal joint. But the thumb has one metacarpophalangeal joint and only one interphalangeal joint. In this video, first we will discuss about the fingers, and then later on we will discuss about the thumb. The metacarpophalangeal joints, these are biaxial joints, whereas the proximal interphalangeal and distal interphalangeal joint, these are uniaxial joints. The metacarpophalangeal joint, it has the flexion and extension movement possible along with abduction and adduction, and the closed peg position is for the first metacarpophalangeal joint, that is of the thumb. The extension is the closed peg position, and whereas from second to fifth metacarpophalangeal joint, the closed peg position is flexion. And in proximal interphalangeal joint, the motion present is flexion and extension, whereas the closed peg position is extension, and the same goes for distal interphalangeal joint also. To have a better gripping and stability while doing the movements or while holding the objects, the importance of palmar arches is there. The arches of the hand, these are the muscular and skeletal structures that allow hand flattening and cupping. We have 3 palmar arches that are proximal transverse arch, distal transverse arch, and longitudinal arch. There are some benefits of these palmar arches. They increase hand strength, and they improve the ability to adjust grasp on objects and tools. They improve the hand's ability to adapt to the shape, size and weight of the object, whatever we are holding. Talking about the palmar arches, the proximal transverse arch, it is a stable bony arch that forms the posterior border of carpal tunnel. This is a concave arch that is formed by the carpal bones. Then there is a distal transverse arch. It is also called as metacarpal arch, as it is formed by first, fourth and fifth metacarpal heads and is relatively mobile arch. And the third one is the longitudinal arch, which is formed along the length of the digits from proximal to distal. How the stability is provided at the fingers, that is at the metacarpophalangeal joint and the interphalangeal joints. Talking about the metacarpophalangeal joint, it has volar plates that are present volarly, that are blending with the deep transverse ligament, and they are providing the stability also at metacarpophalangeal joint. And the main role is that they get stored to prevent hyperextension at the metacarpophalangeal joint, whereas it has collateral ligament, radial collateral and ulnar collateral ligaments present at the metacarpophalangeal joint. The collateral ligament, it is composed of 2 parts: the collateral ligament proper, which is a cord-like structure, and an accessory collateral ligament. They are providing the stability at the metacarpophalangeal joint. The same structures are present at the interphalangeal joint, that is the proximal and distal interphalangeal joints. But the difference is that in the volar plates, they are not blending with the deep transverse ligament and preventing the hyperextension, and whereas the collateral ligament are present to provide stability at the proximal and distal interphalangeal joints. So what are the extrinsic finger flexors? By extrinsic, we mean to say the muscles that are having origin outside the hand. There are flexor digitorum superficialis. It flexes the proximal interphalangeal joint and metacarpophalangeal joint. And we have flexor digitorum profundus. It flexes the metacarpophalangeal joint, and it also flexes both the interphalangeal joints, that is proximal and distal interphalangeal joint, and is more active than flexor digitorum superficialis. And during the finger flexion with the wrist flexion, the flexor digitorum superficialis and profundus, they both works together. The optimal function of flexor digitorum superficialis and flexor digitorum profundus, it depends on stabilization of the wrist musculature and intact flexor gliding mechanism, that is consisting of flexor reticula, bursae and digital tendon sheaths. The tendons of flexor digitorum superficialis and profundus for each finger, they passes through a fibrous tunnel that comprises of 5 transversely oriented annular pulleys and 3 obliquely oriented cruciate pulleys. We have A1, A2, A3, A4 and A5 annular pulleys. The A1 is present at the head of the metacarpal bone, and the A2 is present at the volar midshaft of proximal phalanx, A3 at the distal most part of proximal phalanx, A4 is present centrally on the middle phalanx, whereas A5 is present at the base of the distal phalanx. And the cruciate pulleys, the C1 is present between A2 and A3, between A3 and A4 is the C2, and C3 is present between the A4 and A5. These annular pulleys, they are important to keep the flexor tendons to close to the bone and to allow the minimal amount of bowstringing, and they also enhances the efficiency of the tendons. And the extrinsic finger extensors, they include extensor digitorum communis, extensor indicis proprius and extensor digiti minimi. And the extensor mechanism is formed by extensor digitorum communis, extensor indicis proprius, extensor digiti minimi, extensor hood, central tendon and the lateral bands that merge into terminal tendon. And the passive components are triangular ligaments and sagittal bands. The dorsal interossei, volar interossei and lumbrical muscles are also the active components of the extensor mechanism. Now, what is the important thing in extensor mechanism? It is the influence of extensor mechanism on metacarpophalangeal joint function and interphalangeal joint function. What happens in metacarpophalangeal joint? When the extensor digitorum communis tendon, it passes dorsal to the metacarpophalangeal joint axis. It passes dorsal to it. With the active contraction of extensor digitorum communis, it creates tension on the sagittal bands of the extensor mechanism, pulling the bands proximally over the metacarpophalangeal joint, which further extends the proximal phalanx. But to extend PIP and DIP joints together, the extensor digitorum communis muscle, it requires active assistance. The other active forces that were the part of extensor mechanism are dorsal interossei, volar interossei and lumbrical muscles. So these muscles, they pass volar to the metacarpophalangeal joint, they pass in front of it towards the palm side and creates a flexor force at the joint. But when the extensor digitorum communis, interossei and lumbrical muscles, they all contract simultaneously, the metacarpophalangeal joint will extend, because the torque that is produced by the extensor digitorum communis muscle at metacarpophalangeal joint, it exceeds the metacarpophalangeal joint flexor torque of the intrinsic muscles. And the isolated contraction of extensor digitorum communis muscle, it results in metacarpophalangeal joint hyperextension with interphalangeal joint flexion. the dorsal interossei, volar interossei and lumbrical muscles, they were creating the flexor force at the joint with the isolated contraction of extensor digitorum communis. There will be hyperextension at metacarpophalangeal joint and flexion at interphalangeal joint, making the hand positioned as a claw. This is called as clawing of hand. Understanding the extensor mechanism influence on interphalangeal joint function. The proximal interphalangeal joint and distal interphalangeal joint, they are joined by active and passive forces in such a way that they are interdependent. The movements are interdependent on each other. If the extension is there at the proximal interphalangeal joint, then there will be extension at the distal interphalangeal joint also. The extensor digitorum communis, interossei and lumbrical muscles, they all are capable of producing some tension in the central tendon, lateral bands and terminal tendon that contributes some extensor force at PIP and DIP joints. The contraction of extensor digitorum communis, it alone cannot extend the PIP and DIP joints, but the active contraction of dorsal interossei, volar interossei or lumbrical muscle alone, it is capable of extending the PIP and DIP joints because they are more directly attached to the central tendon and lateral bands. But if one or more from the dorsal interossei, volar interossei or lumbrical they contracts without simultaneously a contraction of extensor digitorum communis muscle, the metacarpophalangeal joint will flex because the each intrinsic muscle, it passes volar to the metacarpophalangeal joint axis. They passes dorsally to the interphalangeal joint axis, but they passes volar to the metacarpophalangeal joint axis. So if the dorsal interossei, volar interossei or lumbrical muscles, they will contract without simultaneous contraction of extensor digitorum communis muscle, then there will be a flexion at the metacarpophalangeal joint and extension at the interphalangeal joint. So to produce the extension along with the extension at metacarpophalangeal joint, they need the simultaneous contraction of all these muscles. And the intrinsic finger musculature, it includes dorsal interossei, volar interossei and lumbrical muscles. The interossei muscles, these are the effective stabilizers and they prevents the clawing due to flexion torque. And these are also the effective abductors and adductors at metacarpophalangeal joints. When the metacarpophalangeal joint is in extension, they increases the flexion torque at metacarpophalangeal joint as it approaches to the full flexion. And in full metacarpophalangeal joint flexion, the abduction and adduction is restricted also due to the insufficiency of fully shortened interossei muscles. The lumbrical muscles, they attaches more distally than the interossei muscles. These are the only muscles in the body that attaches to the tendons of the other muscles. They act as both agonist and synergist for the interphalangeal joint extension, and they also assist in flexor digitorum profundus indirectly during the hand closure. There are other roles and functions of interossei and lumbrical muscles that are already presented in the PDF that was provided earlier. So please go through that. Now let's discuss about the thumb. First of all, the structure, how the structure is there in the thumb. The thumb is having a carpometacarpal joint that is between the trapezium and first metacarpal bone, and it has a metacarpophalangeal joint and one interphalangeal joint. The carpometacarpal joint of thumb, the carpometacarpal joint of thumb, it is a saddle joint with 2 degrees of freedom. It permits flexion, extension, abduction and adduction, and there is some axial rotation also that is useful during the opposition movement of the thumb. The capsule of this first carpometacarpal joint, it is relatively lax, but it is reinforced by the radial, ulnar, volar and dorsal ligaments. The close packed position for first carpometacarpal joint is the extremes of both abduction and adduction. The opposition movement, it is basically the abduction, flexion and adduction of first metacarpal with simultaneous rotation. The interphalangeal joint, it is almost similar to the interphalangeal joints of the fingers, but in the thumb only one interphalangeal joint is there, unlike the other fingers that are having two interphalangeal joints, that the proximal and distal interphalangeal joints. The extrinsic thumb muscles, they include extensor pollicis longus, extensor pollicis brevis and abductor pollicis longus. Whereas the intrinsic thumb muscles, they include the five thenar muscles, opponens pollicis, abductor pollicis brevis, flexor pollicis brevis, adductor pollicis and first volar interossei. During the long-term immobilization, there is a functional position of the hand that is important to be maintained to prevent the contracture during the immobilization. This position includes wrist extended to 20 degrees and there is a 10 degree of ulnar deviation at the wrist. The second through fifth digits at the metacarpophalangeal joint, it is flexed to 45 degrees almost, and proximal interphalangeal joints are flexed to 30 to 45 degrees, whereas the distal interphalangeal joint, they are flexed to 10 to 20 degrees. And in thumb, the carpometacarpal joint, it is partially abducted and opposed, and the metacarpophalangeal joint, it is flexed 10 degrees and the interphalangeal joint is flexed to 5 degrees. One of the important functioning of the hand, it includes prehension. Prehension is basically used to grasp or to hold any object with the hand. For example, if you need to pick something, you will need prehension to do that activity. If I am holding a cell phone in my hand, then I am using a prehension activity. Basically, the prehension is divided into two types: power grip and precision handling. Power grip is also called as full hand prehension, whereas precision handling is the fine movements between the finger and thumb. In the power grip, there are four phases, that is opening of hand, positioning of the fingers with respect to the object, bringing the fingers to the object, and then maintaining the static phase. Whereas in precision, there are three phases, that is opening the hand, positioning the fingers at the object, and then bringing the fingers to the object. So the power grip, it is of four types, that is cylindrical grip, spherical grip, hook grip and lateral prehension. And in cylindrical grip, it involves the use of all the finger flexors. The flexor digitorum profundus, it works predominantly the interossei muscles, the primary metacarpophalangeal flexors, abductors and adductors. They also work in cylindrical grip, and the other muscles that contribute to the cylindrical grip are flexor pollicis longus and thenar muscles and the hypothenar eminence. For example, if I am holding a cricket bat, that is the cylindrical grip. The spherical grip, it is almost similar to the cylindrical grip, but the fingers are spread to a greater extent to accumulate to the size of the object. For example, if I am holding a large size ball in my hand, and the hook grip, basically it is used to carry the briefcase or poly bags in your hand. It is a specialized form of prehension. The main function is there at the fingers only. In the hook grip, the major activities of flexor digitorum profundus and flexor digitorum superficialis, that are the extrinsic finger flexors. In lateral prehension, there is a contact between the two fingers. For example, if you are holding a paper between your fingers, that is the lateral prehension. And the precision handling, it includes the fine movements of the hand and is of three types. One is the pad to pad prehension, tip to tip prehension and pad to side prehension. The pad to pad prehension, it involves the opposition of pad and pulp of the thumb to pad or pulp of the finger. For example, if I am holding a coin between my finger and thumb, that is the pad to pad prehension. In this metacarpophalangeal and proximal interphalangeal joint of the fingers, they are partially flexed, whereas the distal interphalangeal joint, it is extended or slightly flexed. And in thumb there is a flexion, abduction and rotation at carpometacarpal joint, whereas the metacarpophalangeal joint and interphalangeal joint, they are partially flexed or extended. If I am picking a pen from a surface, that is the tip to tip prehension, it is almost same to the pad to pad prehension, but the interphalangeal joints of fingers and thumbs, they create more flexion in tip to tip prehension. And in side to side prehension, it is basically used for the pinching movement. Prehension is between the thumb and side of the index finger. Basically, the thumb is more abducted and less rotated. I have kept some objects to demonstrate the prehension. First, talking about the power grips. Cylindrical grip is when I am holding an object like this. For example, if I am holding a bat in my hand, cricket bat in my hand, then I will hold it like this. This is the cylindrical grip. Spherical grip is when I will hold a ball like this in my hand. Lateral prehension, when I will hold a paper between my fingers, that is the lateral prehension. And the hook grip, when I am holding an object like this, that is the hook grip. Now the precision handling, the pad to pad prehension, it is when I am holding this button between my thumb and my index finger, that is the pad to pad prehension. If I am picking a pen like this way from the surface, that is the tip to tip prehension. If I am holding a paper this way, that is the pad to side prehension. Or more clearly, I can demonstrate with the pen. This is the pad to side prehension. This was all about the biomechanics of wrist and hand complex. For any queries, feel free to text me or email me. Thank you.